Good morning. Happy Friday. Welcome to Six Man. Please take your seat, put your phone into flight mode. This is Six Man session. This is Bob. I'm Jen. Hello, Suresh. I'm quite sure you can figure it out. Okay, so this session is being recorded. This is not well. I'm sure you've seen it many times, but maybe we'd like to take a slow start, read it again, remind you that whatever you said, when you say something, you agree with IETF policies, and so on. Meeting tips. If you're in the room, we would really appreciate if you can log in into on-site tool for two reasons. First, it means that next time we can get a room as big as this one. And secondly, it will help us very much when we manage the queue, because I'm sure it will be questions, right? So yeah, please join the queue when you would like to say something in the mic, even if you are physically in the room and standing next to that mic. Remote participants, please only send audio and video when you're presenting or speaking in the queue. Okay, so we have a Jabber room, chat room. We have on-site tool. Thank you, Yao, for taking minutes for us. Presentation's been uploaded, so if you do not like to look in the screen, you can download them. So, welcome to Bangkok. And by the way, yeah, please check if you have your laptop open, please check which SSID you are on. And I think we all shall be on V6 mostly SSID, so we can ensure it works, eat our own dog food. And if something does not work, please let NOC know. Here is how to report the issue. We just sent an email to support, and our NOC friends will come and take a look. So, agenda. We'll spend a few more minutes on the current status of the documents. Then we have 3 working group items. Ron talking about ICMP reflection. Fernanda will be presenting remotely about making Slack more robust and node requirements draft. Then we have a few individual drafts which been actively discussed on the list. Then if we still have time, we might have few additional drafts which were submitted to the working group and to the agenda before the meeting. So, any last minute agenda bashing? Anyone has ideas they would like to discuss or present? Oh, Eric.
I just have one general comment to make. And that is just to remind everyone that because this is the March IETF, this is when we have a change in IESG and IAB and so on. There's no change for internet area this time. And so Eric is continuing. Eric is returning, I'm continuing. But if you think you want to run for AD, you'll have your chance around this July when the application opens. And now is a good time, though, to begin to think about whether or not that might be interesting. Try to find a current or previous AD and ask them your questions. And if you need to, maybe start discussing with your management or your employer, whatever, to maybe grease the skids to see if this is something you could get some time to do if you're interested. So, thank you.
Yeah, thank you, Eric. Okay. So, document status. We have not published anything since, what was it, Dublin? Yes, since last IETF. However, we have 2 documents in RFC editor's queue. PFLAG is actually being actively edited by RFC editors right now, as I was told. So hopefully we'll soon get to RS 48. And Snack router draft is sitting in the queue. It's ready for publication, but it's missing the reference because it has Snack simple draft as a normative reference. So I suspect it will be in the queue for a while. We have a number of documents in ISG queue scheduled for telechat. It's like IPv6 zone identifier and extension header limits. 6724 update, finally, after all this long and productive discussion, now is at IETF last call, which will finish in the beginning of April. And yes, there are 3 other documents which we sent to ISG, and I believe the schedule for April telechat. Reminder, as usual, we do receive requests for agenda items for drafts which are more in scope for other working groups, but they just need some cooperation with 6 men. We prefer not to allocate agenda time unless it's been made explicit to us by other working group, if it's a problem worth solving, if the solution considered by that working group as the right one, right? So it normally means some related documents been adopted by the other working group, or working group chairs come to us and ask us to discuss the draft. Because sometimes, yes, this group might not have an expertise to know if this particular Spring solution or some network license solution is actually worth considering, right? We know about IPv6, but we are not necessarily experts in any other field.
Yeah, we also sometimes get drafts that aren't really adopted or hardly presented in other working groups. So we prefer to be presented there and get some indication that there's support for it before we spend time on it.
Okay, and I think it's the last chair slide, so we can go straight to the first presenter, which I believe is Ron. I'm going to share the slides.
Hello, all.
Hello, we can hear you.
Well, thank you. Good to see you again. Well, today we're going to talk about an IPv6 reflection utility. Way back in the old days, when you sent a packet, it arrived at its destination looking pretty much the way it did when you sent it. The extension headers generally weren't there. The source and destination addresses were the same. The only thing that changed for the most part was the TTL. Well, that was a long time ago, maybe when I was a teenager. Things have changed. Now, networks change packets while they're in flight. And there's no real good way to know how a packet that you send changes en route to its destination. So this reflection utility helps with that. Next slide, please. Okay, the reflection utility is a diagnostic tool. It's very much like ping that you probably know very well, or probe that you might have played with a little bit, but it's a little less well known. It allows a probing node to determine how a packet is changed between itself and a probed node. Basically, it sends an extended echo message, ICMP echo message, and gets a response, and the response has the original message in it. Next slide. Now, the first question is, do we need this? Do packets actually change in flight? And the answer is, you bet. NATs change the source and destination addresses. There may be multiple NATs between the sender and the destination. Routers can change things like the traffic class, DSCP. Routers can change mutable hop-by-hop destination options. In fact, that happens quite a lot in situ OAM. Routers can change mutable fields in the routing header. In fact, they do that all, when routing headers are present, they must do it. Middle boxes should not, but often do change the flow label. And that's something that this draft would be very, very helpful to diagnose. Zafar. Okay, Zafar is
Zafar
quiet.
Cisco. I didn't mean to disturb you, so you finish your thing.
Okay,
Yeah.
I'll finish and then we'll come back. Okay, next slide. So how does this utility work? Well, the probing node sends an ICMP extended echo request message to the probe node. We've seen this message before in the probe utility. The extended echo request includes an extension structure defined a long time ago in RFC 4884. The extension structure includes one or more extension objects, and each extension object represents a piece of requested information. It also includes a zero-filled payload field. So let's say you'd like to see the entire ICMP message as it arrived at the destination, including the IP header that it's in. There is an object, you send it, it identifies what you're requesting. It has a great big zero-filled field. The probe node gets the message it received, puts it in that zero-filled field, and ships it back. But there are some times when it works a little differently. Next slide. Okay, what are these extension objects? Well, one of them is reflect all. I would like the probe node to reflect the entire ICMP extended echo request that I sent, including the header. That's simple, it works very well, but sometimes it violates the security policy of the probe node. For instance, let's say they don't want to tell you about what natting has gone on. When they get a reflect all object, they'll just send it back with an error code, and the packet will still have zeros in the field. So you can ask for little bits at a time if you like. The reflect request asks for the ICMP extension headers only. And you can see there are other ones. There's HBH request. Show me the HBH extension header and nothing else. There are many more. You can ask, show me the IPv6 header and nothing else. Next slide. Now, what does the probed node do? When it gets an ICMP extended echo request, it formats an ICMP extended reply message. It copies the extension structure from the echo directly into itself, and it overwrites the payload fields, those zero fill fields, with data that's being requested, but only if policy permits. If the probing node is asking for something that the probe node doesn't want to disclose, he'll send an error message and leave those bits as zeros. And of course, the probed node sends the echo reply message back to the probing node. Next slide. Next slide is next steps. It's a very short draft. It's pretty easy to cope with. We already have an implementation, and we're asking for a working group last call. And now questions. Zafar.
Zafar from Cisco. So what draft does not specify is that currently when we do traceroute, the specification allows copy of the invoking packet to be sent back, which does have the content of the packet as it is modified in flight. And many implementation at present are using that method for the debugging purposes that you are trying to solve here. So it would be good to have the description of an alternate way that people are doing it.
I'm a bit confused by the question. You said that traceroute can send back the packet as it arrived?
Yes, the traceroute, when the TTL expires, an ICMP error, time limit or time exceeded or other ICMP error, can send, or implementation do send copy of the invoking packet back to the sender, which sender can then use to see how the packet was modified in flight and debug the information that you're trying to do using this.
Now, I'm not aware of any RFC that describes this or any utility that does it. Are you suggesting that we get the same extension headers and put them on, well, let's see, what are we using?
So what I'm saying,
And make them applicable for trace routes. Because right now, this is only something that you can, the utility is more like a pane.
so what I'm saying is that there are implementations that solve this problem by looking at the trace route as a trace route, or whenever ICMP time exceeded message comes or other ICMP error comes, and they display the content of the entire message, and it could be parsed by the ingress node to see how the packet got modified in flight. And
Are you saying that it would be in the original data field?
is in the copy of the invoking packet.
Okay. In a trace route, when the TTL expires, the node upon which it expires sends back a time expired ICMP message. Now, I don't know of any extension object yet that will send back the entire packet. There is an original data field, but the original data field in many cases is only something like 64 bytes long. It doesn't include the entire packet. And in many cases, it would actually violate security policy to send that back. For instance, in many cases, you don't want to expose what your NATs were doing.
Those security problem exists in your draft too. They don't just disappeared. Okay, and the base RFC does say that as much content as the transit node where the TTL expire would be sent back, and it's up to the transit node to determine what content. So it's another way. What I'm saying is that you should have a fair description of that way in your draft. And then I have another comment, and that is, do you need all of these options, or you can just say that it's up to, it's always request all, but it's up to the node where the packet is processed, the responding node, to, based on the local policies, provide the content back, because that would just simplify your draft a lot more than like putting all these options. I want this, I want that. Leave it up to, because there's a security issue at the transit node where you're trying to get the information from. So just leave it to that node.
Well, there's a reason we did that. We didn't want the size of the response to be greater than the size of the probe. So we wanted to make sure that for everything you asked for, you had to send some 0 bytes to make sure the probe would always be exactly the same size as the response.
Yeah, but that does the feature creeping and complexity. It is always assumed that based on the datagram possible in the response, things would be put in. We can take more offline, if you like.
Okay, yes, let's take it offline.
Yeah, Zafar, I suggest you send the proposed text or your comments on the list as well. So,
Thank you.
Yeah, I'd appreciate text.
So any other comments from the room on this?
okay, please read the draft because it's been a request for the last call, so it's a perfect time to read it.
Thank you.
Okay, thank you, Ron. And next presenter is Fernando, I believe. Fernando, are you online? Oh, we lost presenter. Can you check? Okay, Tim, are you online? Maybe we can move to the next presentation meantime and waiting for. Okay, good. I'll move to your slides in a second. Okay, the floor is yours.
Okay, hi everybody. So this is IPv6 node requirements. So this is a working group document that got adopted in Dublin, I want to say. We did some updates to it, and I'm going to talk about those today. And we still have some other, I don't want to call them contentious, but we still have some things to discuss today. So that'll be good. So do I have control of the slides? I don't actually, no, you do. Okay, perfect. Okay, so what we've done since Dublin, we removed send and mobility from the node requirements. These were almost got removed last time when we updated node requirements. And so this time we decided to remove it. It doesn't mean that they can't be used. It's just we don't think there's relevance to general nodes anymore for either of these. So that's what we did. We removed it. I know Fred sent a note about this. Fred Templeton sent a note. I think, you know, we as the authors, John, Tim, and I talked about it and decided to still remove it and see if there are any other objections. We added a discovery of translation prefixes section, thanks to Nick. He added some text or wrote us an issue and we did that. And then last time we had a very healthy discussion about Rule 5.5 and 7624. And so we've upgraded that from a should to a must in the current revision. So that's the work we've done since last time. Next slide. Plans. So a couple things. As 7624 has settled now, I think we need to take some of that text and talk a little bit about the updates in the node requirements docs. So we'll do that. The updated extension headers, we talked about 6-man E extension header limits. I know that's going through the process. We should point to that. The current node requirements actually, last time we added some text about extension header processing, which is basically turned into that draft. So we need to take that text back out and just point to that RFC and say, hey, use this if you're really into your extension headers and you want to read about the limits and how you should handle that. We kind of snuck some normative language in the previous version of V6 node requirements.
Tim,
So
so that document is currently informational, so it'll be a little more complicated.
Yeah, yes, I think it's just telling people there's the information for the, extension header limits. But yeah, that's a good point, Bob. You're right. So we'll have to massage that text correctly and do the right things. We need to add, and this is just a reference to PD per client, and talk about when to use it or why you would use it and when not to use it. We had a request for DNR to add that as a way for people to do DNS, and we had PCP as another request issue that somebody has raised. Go ahead, Eric.
Hi, hi, Tim. Eric Venk.
Hey.
No specific here. I just wonder why you are adding, like Bob said, the informational extension header limits there. Will it be a may consider?
Yeah.
Honestly, I would frankly prefer not mention it at all. My own point.
Okay. Yeah, so the tricky thing here is we have normative text in there now in the old node requirement about header chains and how long they should be. And so I don't know what we want to do with that text. The previous version of node requirements has 2 paragraphs about extension headers and the limits and what should happen. So we're in a little bit of a pickle that way. We can just leave it. I mean, that's one option, is we can just leave that text alone, but it does kind of stand out as a little odd, would be my only. So
again, my purely personal is that say nothing about limits in the requirement document.
Okay, so you remove, so even remove the current text that's in there in general, Eric.
I would need to review the current text, to be honest, right? But I would not like to see hard limits or minimum hard limit or whatever.
Okay, that's fair. Thanks for that. Okay, so here's the 2 things that I think people want to talk about. There's two things we've discussed on the mailing list that we need to sort of, as a group, get together and discuss. One of them is hosts must implement 8028. We had a very long thread about this. I think I was sort of on the fence of, I think I suggested a should here, and the working group made it very clear to me that they really wanted this to be a must. So we will go ahead and make that change, add that to it and say, hey, we think this is really important for the multi-prefix problem. So based upon that, we'll do that. Go ahead, Lorenzo, if it's about 8026, and then we can talk about PMTU next.
Oh, it's about 8028.
Yep.
I would challenge anyone to provide evidence of a working implementation of 8028. I don't think it can be implemented correctly. And I don't think we can put a must in there, referring to an RFC that can't be implemented.
Yeah, I'm gonna try. I feel weird arguing with myself, right? This is the argument I made in Dublin, and I said, I don't think I've seen running code for this. I'm not aware of anybody who has actually been able to make this work, to my knowledge.
8028 tries to do something reasonable. It's just like written in a way that's like impossible to understand and also impossible to implement. So I do agree that we should have something. It's just, yeah, from a process perspective, if anyone has an implementation of 8028, please speak up.
Please. I mean, yeah, I think the move might be for now is to make this a must and see how we get on. And I think that'll get a reaction.
I put myself in the queue, Jen Linkova. So based on the recent email thread, which Fernando and I participated, I start feeling that we have different understanding what exactly 8028 suggested, right? So because my reading is it's necessary to implement source just routing and send the same packets of existing flow when you already have a source address to send it to the right next hop. It has nothing to do with selecting the source address and so on. But I suspect, yeah, we have different readings. So maybe we need a document, not necessarily this document, and most likely not this document, talking about in general behavior of multi-home, of host behavior in multi-homed environment, and what we expect it to do, and what should be implementation details hidden from like the network, right? Which we do not need to specify, but what behavior we expect.
Yeah, I mean, I think one thing, obviously node requirements is not the place to hash out multi-prefix. So one thing we could do is just wait to the last minute and see what happens in the working group and with V6 ops and 6-man documents about this problem.
But this might actually be a good place to sort of write down what we have, to clarify what we think the RFC says.
Yes,
we have consensus on it.
Yes, that's true. We've done that in the past. Go ahead, Lorenzo.
Yeah, just to clarify what I mean, I think 8028 starts going wrong in the 7th line, where it says that what does it say? Let me read it. The selection of the source address is done before the first hop router for that packet is chosen.
This is errata for this, and I see David already jumping to the mic. There is errata which clarifies that, so you can check errata section.
If this references 8028, it should also reference errata 7009 on this, which fixes that exact sentence.
Okay, that's noted. Thank you. That's good info.
So yeah, I think 8028 kind of specifies implementation details, right? But what we really need maybe, we'll say this document or maybe separate one because it might be bigger effort, requirements, right? What we expect the device, how do we expect the device to behave? How it achieves this behavior, it's implementation specific. But on the other hand, I've heard that there are some implementations of Rule 5.5 in some operating systems. So I would love to hear from those implementers how exactly they did it, right? And how exactly they do they support what 8028 suggests, or they do something different which ends up in the same behavior?
Yes, they do something different. We've tested this. So we've had some experience with this, and it's slightly different than what 8028 suggests. They've come up with slightly different algorithms to deal with this problem, or at least the 4 implementations that I'm keenly aware of 5.5. So, I mean, I think Ben from the IOL sent out his email that said, you know, they've seen a lot more clients supporting 5.5. 8028, I can't remember. He'll have Ben's not here, I don't think. He'd have to remind me what the catch is that they don't do. I don't remember offhand.
Yeah, I don't think that, I don't know. I mean, we have the implementers here.
Yeah.
One of them is studiously looking at his iPhone right now. Like Android doesn't implement any of this. And I don't know I don't know if Tommy's here, but
This is Ted Lemon. I'll just say that I'm actually studiously looking at my phone as I write a note to our testing department about the fact that I don't know how this works, and maybe we should add some tests. So sorry.
Okay, I quickly jump to the queue here. I'm very, very serious to finally get to the hackathon next time to test 5.5 and multi-homing environment. So Ted, you are welcome to join in Madrid, please.
Yeah. That's
so
a good idea.
I think,
We have, yeah.
I think the 5.5 implementations we have kind of work and like probably address some subset of the use cases that would be addressed if you implemented something like 8028, assuming you read the errata. And I don't know that anyone implements that actually for real. So I think we as a group need to figure out 2 things, right? We need to figure out what's supposed to work, and we need to figure out what does work today. And
Yeah.
I mean, much as I would love to put this stuff in there, I just think it's premature.
Yeah. Okay. So I think that's good feedback. You know, my instinct here is to wait. You know, I don't think we have to make, you know, this document is not going to be ready to go by the next IETF. We've got couple of updates to do. So I think we can sort of slow roll this and see if maybe we're lucky at the hackathon in Madrid, we sort out what we want to do and we can write it down here. Would be, I think, our perfect world. And if not, we'll address it down the line. It's becoming my instinct on this. I'll talk with the other authors and see what we think. Okay, so that's 8028. And then we had a lovely discussion on the list about old school MTU, the classic 8201 version, and using I'm going to screw up this acronym, PLP MTUD, the newer version. And I actually took the text at the mailing list. There was a nice discussion and we seemed to come to a consensus on. Old school, yeah. And so, yeah, that's kind of what we're going to say. We're going to say they must both be done. I don't think we want to throw out old school path MTU discovery, but I think we want to encourage people using the other one. I don't know if this is contentious. I didn't hear a whole lot from implementers on this one on the list. So I'm curious if anybody balks at doing both of those. Being that no one's running at the mic with pitchforks, I'm going to say we'll go ahead and do that. Okay. I think that's the most.
Pitchfork at Does anybody know if like, I don't know, do OSs like Linux implement PLPM2D? They do. Cool.
It's not on by default. Yeah, it's not on by default is the little story here, Lorenzo. You can do it. It's there. It's just you have to go twiddle the bits.
Okay.
Yeah, next steps. This is easy. So a couple things, our goal as authors, we talked about this. We have a whole series of open issues. I put the link there. Please go and add them if you have them. Some people have found it very nicely, and some of those issues we're addressing, like DNR, those types of things. Please feel free to add them there. Our goal is we currently have, I want to say, 9 or 10 open. we'll close all of those. That's going to be our goal for between now and 23. We kind of set an author's goal out to get those resolved. And then obviously we're not closing the door. So if you read it and have new thoughts that you want to bring up, please feel free to add them. And then, I think we're looking at probably in November, trying to aim for wrapping this up, which means it'll probably be a year from now, but we'll aim for November. That's it.
Okay, so who actually read the draft? Come on, thank you. So yeah, I will encourage people to read it because I think it's a fundamental work here, right? If later your laptop or phone does not work as well as you want it on V6 only network, do not complain. Maybe we just missed something in this draft, right? So please, please, please read it. So thank you, Tim. I do not see anyone else in the queue. Oh, and I see Fernando is online. Okay, great. I'm switching to
Thanks, guys.
Fernando's slides.
Hi there, can you hear me?
Yes, loud and clear.
Okay, perfect. Apologies for the delay. So this is Fernando Gont. I'll be presenting the document, Improving the Robustness of Slack to Flash Renumbering Events. Next slide, please. So this is essentially a document that has been around for quite a while. Essentially, it proposes improvements to Slack to more gracefully handle flash renumbering events. The issue of flash renumbering events has been documented and discussed in a document that was produced by B6 Ops, RFC 8978. And this document over time, so the document originally contained not just the current mitigations, but also other stuff. And over time, what the working group decided was to essentially keep just those, simple improvements that there wasn't much discussion about. Next slide, please. So these are essentially the changes since the last revision. The first of the changes was improvement in terms of rather than just referencing the section that we were updating, we have included text or the changes as patches like old text, new text. What is the text that we are replacing? So that is like way more clear. The other thing that we did, this was based on feedback from Suresh, if I remember correctly. For the case of the mitigation, for the case where we introduce a change that allows honoring prefix information options with a lifetime smaller than 2 hours, we now include a discussion that will, based on the thread model of neighbor discovery, you are trusting neighbor discovery messages anyway. But if you are concerned, you should consider employing send or router advertisement guard. And finally, the other change that we have incorporated is that we have augmented the table that we had in Appendix A regarding how many packets you might probably have to send for different loss rates in order to, for one packet to be received by a host. This was, if I remember correctly, a request, a suggestion from Lorenzo Coliti. So those are essentially the 3 changes that have been incorporated into the current version of the document. Next slide, please. So from the point of view of the authors, I guess the question from us is whether the document is ready to be sent for working group last call.
Give it to you, I'm those. I cannot say anything, I'm those.
So any comments from the room?
Fernando, this is Suresh. Like my meet echo is not updating, so I did look at the new text, and I'm happy with the change. That like shows what is getting updated. Thank you.
I took a quick skim through the document, didn't find it. If you take the default parameters that are suggested in the new default parameters, right? What level of packet loss will result in the device disconnecting? Do you know?
I don't remember off the top of my head, but I don't remember off the top of my head, to be honest. So what we did do was to actually use values that were even, let's say, larger or more loss resilient than the recommendations that you had in the RFC that was describing the topic. So we were even more conservative about that.
We should probably update that, because I think that is also not, it's not pessimistic enough, unfortunately. Anyway, maybe that's something that shouldn't block last call. I think we need to figure out, though, if whatever we put here, will be put in by like router vendors. And if 50% packet loss will result in like devices disconnecting, then we need to change these values.
So yeah, we have like the default is actually even an increase of what the specs say nowadays. But there's also this table that we have produced so that folks can override that value if they wish. But it's a valid comment. Like I believe that it could be addressed as part of the working group last call feedback.
Ted Lemon. So a couple things. I guess the first thing is I would like to see this go to last call. It's been a long time, and we're never going to get it perfect. It's always a learning experience. So we may find that we need to do a follow-on or something like that anyway. But not having any guidance at all, or leaving the guidance the way it presently is, I think is not the right thing. So, and also just, selfishly, this is a good time for me to do a last call review and make sure that I don't see anything that needs to be tweaked. So for me, this is a good time to do a last call. I don't know if that's true of others, but certainly I favor doing a last call now.
Great. So we have a reviewer. Thank you, Ted.
All right. So yeah, I think for this, doing a working group last call will be a good way to get more people to review it and comment. So we will plan on doing that after, next week. Thank you, Fernando.
Thank you.
And now Adrian. Oh, hold on. I need to know how to do that.
Wow, that screen is a long way away.
Okay.
So yeah, anyway.
Yeah.
Okay, sorry, working group, that this is a bit of a late-breaking draft, but we got to it as quickly as we could. What we're trying to do is address a teeny issue in the SRv6 SRH description. SRv6 processing is defined as copying an entry from the SRH SID list into the destination address field. And thus, the SID list is specified as being a list of IPv6 addresses. What happened was we came across SRH compression, which made the entries in the SID list not IPv6 addresses, but some form of compressed version, so that there's a function that is applied to the SID list to create the destination address. That got spotted during IESG evaluation, and the quick fix was to make the compression ID an update to 8754 with the replace CSID as a specific exception. But along the way, the AD suggested that it would be neat if we had a clarification so that future work could just sail through. So really quickly through the background, 8402 is the architecture. The architecture doesn't actually talk about a SID list, but it does talk about lists of segment identifiers being IPv6 addresses. 8754, which comes out of this working group, defines the semantics and encoding and processing rules of the SRH and makes specific statements about the segment list, the SID list in the SRH being a list of IPv6 addresses, and that you explicitly copy them one at a time into the destination address. 8986, which is back to Spring, stretches it a little bit because it says the SID list contains a 128-bit entity that is locator function argument. Let us not now debate whether that is truly an IPv6 address or not. I think that one's gone. What the effect is, though, that according to 8986, you still copy an entire entry from the SID list into the destination address. And then lastly, the thing that's come along, the compressed SID list is a way of not having to put a whole 128 bits in for each segment, which then, of course, breaks this thing that the SID list contains IPv6 addresses, and there's some kind of function applied.
Stop using the timers, I think.
So that's why we are where we are with this document. So what this document tries to do, it aims to make a clarification that what is in the SID list is not necessarily IPv6 addresses, but that the DA is derived from the SID list applying some magic function, which may be a trivial copy, or maybe something else. Our intention is not to change the SRv6 architecture, not to change the SRH encoding, but to enable future work to go through without having to do an update each time and get chewed up by IESG processing. So my questions are, do we need this draft at all? Okay, the compression draft has already done an update, so maybe we're done. But the ADs thought it would help in the future, and it might help for future use cases. Should this document actually be marked as an update to 8754? Currently, it's positioned as a clarification, but it looks more and more like an update the more we talk about it. Should it also then go and update 8402? Maybe, maybe not, because there's no actual definition of the SRH in 8402. And where does this work belong? Is it 6-man, where 8754 came from, or is it Spring because Spring is pushing the new use cases? What we would do, depending on the answers, is revise this, put in updates text and explanations, change it to standards track, and send it to the right working group. Thoughts? Anyone care?
AD hat on, thank you for looking at this, for doing this. Maybe I am the only one, or maybe Eric and I are the only two who care. But thank you. AD hat off, I think updates make sense. I think doing this makes sense. But can you remind me, because that's a lot of context, it's been a long week. The meaning of the segments left when there's a replace CSID, that remains pointed at the replace CSID until it's fully consumed?
Yes.
Okay. Yeah, because there's also we did have an erratum that I think Joel filed to clarify that segments left refers to the number of 128-bit segments in the entry list.
Yeah, I think segments left really means segment list entries left.
Entries left, yeah, exactly. If you feel like throwing that into this document as well, I wouldn't object to that either. So thank you.
So my personal opinion is it's worth clarifying because apparently it had to be clarified. So makes sense to me that what's in the destination address field of the IPv6 header should be an IPv6 address. Seems fairly simple. I'm not exactly, I don't personally object to doing it here, but I don't have a strong opinion on, or at the moment, on whether it's standard track or informational or whatever.
I think that's just a process thing. If we do an update to a standards track, I think we have to be standards track.
Janikovic, Chair Hudson. Bob, maybe we need to talk to Spring chairs.
Oh, yeah.
And yeah, and ADs. And unless, well, I do not see anyone in the queue. So if the group has strong opinion or suggestions, I see Nick said in the chat that he does care. But yeah, so we obviously would like to hear the group opinion, but in parallel, I guess we'll talk and find out if there are any strong opinions about where this work belongs. Again, I think this work needs to be done, and it's a kind of borderline, so I do not think it really matters as long as it's done, but we can find the best home for it, yeah.
Yeah, okay, so we'll tidy up the document and then make sure it's seen by both working groups, and beyond that, it's just process.
Yeah. So obviously, I think document should be reviewed by both groups, which group officially owns it, to be decided, but I'm sure we'll find a home for it. Oh,
Yeah, thank you, Suresh Krishnan. So I personally think like 6man has a closer connection to this draft since it's mainly about 8754, not about 8402, even though it's like related, like, Erin was saying in point number 3. So I think like 6man is the right place to do it, but I think we can certainly go talk to Spring about it and like at least like maybe ask for a slot next time or like send a pointer to the list and kind of talk about it. But I think the Spring side of the story is done, right? Like if you look at the SRVC's compression like draft that kind of got us into this thing, right? It actually has the update and has some text already. So I think this is really like for 6man to kind of close the gap. So I personally prefer to be in 6man, but no strong feelings about it. And maybe a combined last call or something like that might be easier instead of pushing it around. Thanks.
Yeah, I mean, it's interesting because the beneficiaries of this will all be Spring. But yeah.
Yeah, again, I think we might separate the discussion about who reviews it versus who officially owns it, right? And yeah. Alvaro?
Hi, Alvaro Rotana. I'm one of the Spring chairs. Yes, I believe that if this work is going to be done, it should be done here because it updates 8754. I just want to point out that when compression work was going on, we, Spring, consulted 6man several times on different things around 8200 and 8754 and et cetera. And one of the questions that we asked, of course, was about whether compression should update any of these documents. And all of the times we walked away with no, we should go as we are. And in fact, the compression document made it through the ASG without an update. I am not an AD. I don't want to be one right now. But I don't know. It feels like this wasn't part of the original process. So on one hand, I'm not going to stand in front of the progress of this document, but I don't think it is necessary. Having said that, with my Spring hat on, yes, let's please discuss it with Spring if it's going to go forward. It is your document, your working group.
Yeah, it's interesting that there is an individual ID approaching Spring that makes another variation on what's in the SID list. So what's there is not an IPv6 address, and that's the encryption draft.
Okay, I guess it's me, and I can, hold on. Ah. Yes. Okay. I'll do it. My slide. Now I'll get control. Yeah. Hello, Jelinkova with, again, prefix-specific link local addresses and Slack robustness. Please raise your hand if you have no idea what I'm going to talk about. Okay, because I have 10 minutes, and I'd like to focus on new things as well, but I do not want to get people confused because they don't know what the proposed solution is. So, quickly, if you renumber your link, for example, if it's CPE getting new DHCP prefix, or if your host moves to another link without noticing it, for example, your automation came and changed the VLAN on the switch port or .1x reauthenticated the port and so on. In both cases, it's actually the same situation. V6 prefix changed, and your host most likely will end up with two prefixes, only one of them working. Unpleasant situation, users are unhappy, I am unhappy because I get tickets. Now, Rule 5.5, especially with the most recent update, which is currently at IETF last call, interestingly, if you have two routers advertising two prefixes, not one router advertising old prefix and new prefix, Rule 5.5 actually helps because your client has two prefixes, blue and pink, each one advertised by different routers. One of them is now unavailable because you moved to another link. Your neighbor unreachability detection detects it. 4861 tells you you should prefer reachable default gateways versus over unreachable. So you're going to select pink reachable router, and as a result, you will select the pink source prefix. All should work, right? So how we can achieve this if it's the same router still and just prefix changes? The idea is you start sending arrays from different link locals, so your old router and new router advertising old prefix and new prefix look like two different devices. So, so basically, as a result, right, if your client moved between two links or links just renumbered, for client it looks like a new router appeared, an old router disappeared, and it's basically kind of multi-homing scenario in which, in one case, the old router just gone. So basically, what we are proposing, first of all, for managed networks, it's very easy. I'm doing it, it's just a configuration. It's not even in 6 months scope, right? You just do it, configure your link local address where you want for each VLAN separately. So when my host moves between VLANs, it's always this different link local address of the gateway. For CPE cases, I think it would be beneficial if the router just takes the prefix, put it in add prefix list, and just generate a random stable interface ID using this specific prefix as a prefix parameter. And then it just basically behaves as a router which has only one PIO, and if you have multiple prefixes, you behave like multiple routers, each one has only one prefix. Basically, I'm reinventing PVD here, kind of, right, without expecting client support. Yeah, so that's what I'm actually doing in my network, right? I have VRP group, and the easiest way is just use global prefix as interface ID. Thanks God we have /64, right? You can take the network prefix and move it to interface ID. Okay, so I presented it in V6 ops, and I was told I should go to 6man. I presented it here last time. So since last presentation, some concerns were raised in Dublin and then in the list. Tim made a good comment about some routers just could not have multiple link local addresses. Well, text clarified, it's a feature which could only be enabled on the routers which do support multiple link local addresses. Fine. If you cannot do this, just don't do it, right? And by the way, if the router supports IPv3, I'm quite sure you can do multiple addresses because the router I tested, some of them do not let me do multiple physical link local addresses, but you can have one link local per VRP group, so you can have many. At least Juniper just sends array from all of those virtual link local addresses right now. Tim also said, yeah, there are setups when the router might have many prefixes configured, which means it's going to send multiple arrays and it's going to be very bad. Again, the proposed mechanism is optional. It's an optimization which does not need to be enabled everywhere. So if you have, I don't know, a data centers when your hosts do not move between VLANs, you don't need it. If you always have the stable prefix, you don't need it. So far, I see two primary use cases as cases when link can be renumbered, which mostly DHCP-PD case, when your delegated prefix changes and prefix advertised in array downstream could change. And it's scenario like enterprise network when your host might move between different subnets without noticing it. So yeah, this feature might be just enabled there. Yeah. Oh, that's horrible. We're going to send too many arrays now, right? Again, this is optional optimization, which could be enabled only in scenarios when you need it. And to be honest, again, I expect that in most cases, what's happened, you have global prefix, maybe you have ULA, right? And then you change your global prefix. So strictly speaking, I do not expect more than 2 arrays instead of 1 being sent in this case, right? And the draft has been updated to make it explicit that to reduce the energy consumption, it would be good if the sending device bundles them and sends all those arrays more or less together. So apply the same sending logic and does not make your phones waking up too often. Yeah, Fernando mentions that, yeah, we probably need to update 4861 because the 4861 uses the term the link local address of the router, which kind of assumes it must be the only one. I looked at 4861. There are 7 cases when it's mentioned, 5 cases covered by this draft. The link local address mentioned in array format, and the draft already explains how you send array in this case. Redirect also covered in the draft. And there is a discussion section about why in original 4861, discussing why the router should have the same link local address all the time. There is only 2 places when we might need more text, which is talks about redirects again, because 4861 saying when you have multiple routers and you send redirect, your router needs to know the link local address of correct next hop. So it would be desirable that link local addresses needs to be somehow known in dynamic routing, right? So I'm quite sure it could be done, especially because the draft suggests that the router might have a stable address, stable link local address, like it does now, which doesn't depend on the prefixes which are changing. Exactly for cases like dynamic routing. Okay, open question. Fernando also raised concerns that current proposal kind of implies that if prefix is removed, your router does not keep state, your link local disappears. It does help devices which do Rule 5.5. Slack renum document in 1996 RFC said that after your prefix was removed, your router needs to remember that and keep sending arrays with preferred lifetime, like forever, for a long time, right? And in this case, all devices, no matter do they support Rule 5.5 or don't, would notice that. However, how we got to this Slack renum discussion in the first place, routers sometimes do not know that they used to have a prefix which they still need to advertise with 0 lifetime. So I've been thinking about that, and I think actually there is no conflict. So in all those cases, if you have a prefix which you're going to advertise in PIO with 0 lifetime or non-zero lifetime, you do it from link local address dedicated to this prefix. If that prefix used to be configured and now you're just trying to deprecate it, you still advertising from the old link local address. If you do not have, if the router doesn't have any previous knowledge about its previous state, well, then Slack renum doesn't help either, right? So I think there is no conflict actually, because the current draft basically said, put only one prefix in add prefix list and generate array as per 4861 with whatever lifetime you want to put there. David, you want to ask? No, okay. Yeah, interesting question. Currently, the document status is specified as proposed standard because I'm trying to update 4861 and 8028, by the way, because 8028 saying a host should select default gateway for each prefix and prefer those gateways based on the source address. But I think it needs to be updated saying that it should prefer reachable gateways. Because if you have two prefixes, two routers, and one router is gone, there is absolutely no point trying to prefer unreachable gateway because you're not going anywhere, right? So, and I think Brian agreed in email thread that it might be a useful update. So I'm actually happy to see it as an optional experimental feature, but then, yeah, there is some problems with updating standard tracks, or maybe we can just do 8028 update separately. And it's here today. The previous presentations, people have some ideas about what to do with 8028 anyway. So, opinions. Is it a good idea? Is it a better idea than it was last time? Comments, suggestions, adoptions?
David Lamparter, multiple things. The first one in 4861 is section 6.3.6. It says the policy for selecting routers from the default router list is as follows. Routers that are reachable or probably reachable should be preferred over routers whose reachability is unknown or suspect. I think that answers a whole bunch of things that you just said, and you should just reference that. So I will send that to you in an email.
No. Like we have, like if you look in the email thread Fernando started, he believes this. In this case, it would apply for per prefix set of next hops.
Yeah, of course. I mean, it's per next hop.
So idea is if you have prefix say with next hops A, B, prefix 2 with next hop C and D, you would prefer one of two if only one of them is reachable for each prefix, but you might not go to look at other next hops for other prefix because you still should, I think it's minor clarification 2028, right? I think we all agree that it should be like that, but it might be read differently. So I understand what you mean, but I think it would be worth clarifying the text.
Yeah, okay, there definitely needs to be something about this. Let's put it that way. Second thing is, you said it must be disabled by default. I guess I'm a little bit biased as an implementer because I would give a little bit of trust to the people writing the code for this and hope that they don't just add an infinite amount of link local addresses and keep spamming things. Yeah, this one must be disabled by default. I guess it's fine. I'd rather do something sensible when I write code for this, but
yeah. So like, you probably heard that it was some document issued recently about using must and should. And now, because we have to justify the should, I would like to hear your suggestions in which cases you should enable it and which cases you should disable it. The previous version was saying it should be enabled if you have, what I'm saying currently, it might be enabled still if you think that interface might be prone to flash renumbering. If you know you have DHCP client and on this interface you put addresses from PD prefix, then it actually makes sense to enable it by default. But I would love to hear from implementers.
Okay. Last thing about the sending arrays with the prefix lifetime as zero. So I know that if I implement this on a Linux router of some type, I can send arrays from a link local address that is no longer configured on the system, in theory. I'm not entirely sure that's a good idea because there will be no DAD for that address anymore, as theoretically something else could claim that address. It's a theoretical concern. However, it might still be a good idea, and maybe we should look at that, discuss that a little bit, and come to an agreement on that.
Looking forward to the discussion. Tim.
Okay, Lorenzo?
Oh, that was it.
A few things. I think, yeah, I mean, I think the lifetime zero address isn't really a problem. You can send a zero lifetime array from any link local address, right? And like that'll just clobber the lifetime. That's how it works. So
So you can use stable address, which I'm suggesting, right? Which is not tied to any prefix and just stays whatever. Yeah.
you can also use the new one if you only have one.
But then if you already know the prefix, I do not see a problem, right? Just yeah. Okay.
So does this? I mean, I don't think it's mentioned in the draft, but this will also make it a lot easier to support multi-prefix multi-homing with one router, right? So maybe you should say that in the draft. I don't think it does it?
No, I don't think it does. I think I need to remember what we put into this multi-homing RFC use case, like multi-homing use cases like a long time ago, because that case was discussed like when we were working on that draft, like in 2016.
I think that probably if you don't do it like this, it probably means you have to like withdraw the routes and so on. It's probably quite difficult. So this would make it a lot easier. Basically, for every upstream you have, you can like basically effectively you're making a virtual router. And so that's another thing. You could try to cast this instead of being, like multiple link local addresses, you could say virtual router. That's kind of what VRP says. But you've already written it. I think it's the same. One thing I wanted to say, though, is that you're focusing on reachability, but there are other options in that you. So what you're kind of trying to do is you're trying to basically say, well, you're not invalidating these old options that were sent by this old thing that's no longer there, but like you're not preferring them anyway. So when there's a renumbering event, the host will say, well, that thing technically still has a non-zero lifetime, but it came from someone who's not there anymore. And because I have to prefer the new thing, I have to use the new router and I'll use the new source prefix. But that doesn't extend to any other options like the DNS server or the prefix 4. And so that's something where this is kind of a nice hack, but we ought to maybe say something about that, right? So for example, if the previous link local address router advertises a DNS server that's off link, and then you sort of renumber, and now you have the new link local address, you still have to invalidate the old DNS. That's like there's nothing. Otherwise, hosts will keep using it or could keep using it.
I think, yeah, it's a very good point, but I think we kind of started. We're getting into very uncharted territory of what host needs to do in multi-homing, like all this information you get from different routes. It's basically PVD, I believe, right? How I understand PVD. As I said, we probably need to define what host needs to do in general. Let's forget about how we need to tie DNS, prefix 4 and options to a router and invalidate all options when router disappears or not. Maybe we do, right? But I think it's exactly what we need to define for multi-homing, multi-router host behavior, right? Because yeah, I agree, we have been focusing on addresses, but yeah, information about DNS and other MTU at the end of the day, right? Like, yeah, we can basically everything your router advertises you might be invalid if you get it from another, like if you switch to another router.
I mean, I guess what I'm saying is like this is kind of a nice hack which relies on stuff that like is already written in the RFCs that, so when people implement those RFCs, it'll sort of like start working. But I think saying, note that this doesn't help you, for DNS. And I think, like I said, if we as Fernando's draft does, basically we do have to invalidate old information if we know what it is. And so that's kind of okay. Doesn't help the roaming case, but
yeah, so basically
maybe just mention that.
I don't even know if you require anywhere to map DNS information to router advertising it. Most likely no, right? So if you get...
It's not written anywhere, no.
Yeah, so I suspect, yeah, it's basically will be even harder than Rule 5.5 when you need to remember which router advertised which prefix. Now, you might also want to remember which router advertised which DNS prefix for and other stuff. That's why in CLOT draft and V6 ops, we explicitly saying if you start seeing inconsistent information, it's like configuration error, and you do CLAD for prefix and not6 for pairs, right? And that's it.
It's all very ad hoc. I feel that like what you should try to do maybe is you should see if you can write this in terms of like implicit PVDs. You could basically say, well, it's now like each link local address is now an implicit PVD. It might work better from a text and sort of like readability perspective. You should try to look at that.
Okay, yeah, thank you.
Okay, Tom?
Tom Hell from BT. I have a wonderful use case that I think this suits so very well, and I'd be really happy to see this adopted. I think that the one thing that we need to test in the situation where you have a single router with a fixed line uplink and a mobile uplink, and you want to do failover from one to the other, and they've got different prefix delegations, we're going to have to test, I think, the interaction between valid lifetimes to 0 and preferred lifetimes to 0, and using Gula to actually, figuring out the order in which, when do you advertise to 0, when do you remove the address, in which order, thinking about the stub DNS resolver that we'll have on that device, whether we use a separate address for that, for example. So I think it's quite an interesting idea.
Yeah, so like that's why the draft has section actually about stable address, because for example, if you want to advertise the router as DNS resolver, right, link local, yeah, you do not want to change it all the time. So that's why there is a section on top of prefix specific. You might have a stable, proper, normal link local address, which is stable, does not change no matter what prefixes are. Yeah, so I agree. We shall talk about that.
Yeah, I think that's going to be great. We're going to test that.
Philip, if you can be quick.
Yeah, just a quick note about the DNS bundling case. I fear we end up that we have to do the same magic as Rule 5.5 for DNS2, because we have DNS views. We have a lot of weird setups with CDNs that might react quite differently based on where a query comes from. And so in the end, we end up to do everything. We will need the same as Rule 5.5 also for DNS and bundling it to the prefix.
Yeah, thank you. So basically, we're converging on implicit PVD behavior. Yeah, but yeah, thank you.
Good, thank you. Do you want to give Fred slides up? Hi, Fred. We're getting your slides up.
Hi, do you hear me?
Yes.
Okay, great. So this topic is send CGA for Omni links, and I've got the drafts listed below that are affected by this. Next chart. So the problem statement and solution summary, we have gateways and proxy servers form an interior topology joined by IPsec tunnels over underlying internetworks. So we have our Omni Arrow gateways and proxy servers here joined by IPsec tunnels. So they're secured at the link layer. And in the lower portion of the figure, what you see is an Omni link as an adaptation layer overlay configured over the interior topology. We want for the neighbor discovery messages over the Omni link to transit the link in a single hop, but they may traverse many underlay segments. And the clients and proxy servers need a way to authenticate neighbor discovery messages at the edges. And we're looking at send as the mechanism for doing that. So only at the edges where we have the packets traveling over unprotected internetworks do we need to apply send. In the interior port where we have IPsec tunnels, send's not needed. But at the edges, we do need send. Next chart. So the send options that are useful for IPv6 neighbor discovery message authentication include things like the authentication option, the certificate option, timestamp and nonce, and several others defined by RFC 3971. Send cites SHA1 as the authentication default, but it's not as effective as some of the newer alternatives that can also be used. Send cites cryptographically generated addresses as the addressing default, but CGAs are incompatible with remote attestation. So SEND permits the use of IPv6 address types other than CGAs. And we're looking at alternative certifiable IPv6 address types with cryptographic elements needed. We're looking at new and existing candidates for those address types, including RFC 9374, to consider to use for the OmniLinks. SEND defines mechanisms, not operational practices. So the issues for such as PKI are operational concerns, not protocol concerns. And so for these reasons, for the use case that we have for the OmniLink, we'd like for the working group to consider reinstating SEND in the IPv6 node requirements document. And I'll take questions now if there are any.
Eric?
Hi, Fred. This is Eric Ving. I just wonder, do you want to make a SEND BIS document updating the crypto in it?
Do we think it's necessary?
I am asking the questions to you.
I'm not authoritative enough to say that 3971 can't be used as it is with the different encryption alternatives.
Okay, and
I don't know.
And the last point, I really no head, obviously, right? Strongly object about your last request. SEND, we should not be back in IPv6 node requirement. I don't think it was ever. Just for information, right? Now, speaking for the second time in the week as a Cisco employee, we had the SEND code in iOS router, and we had to remove it because nobody was using it. I think it's a clear message.
Okay, well, we have a use case for it.
It does not prevent you to use SEND, obviously, right? What I said.
Right, David?
Lampard, much of what Eric just said, and I would say that I would really like to ask you for actual implementation and operation experience here. Do you have some setup that is running with this using SEND? If yes, can you put together, I don't know, 2 slides next time you present this, how that went, and if there were any experiences from that? And I also don't see why SEND would be in the node requirements just for specifically the fact that this mesh routing setup wants or needs to use SEND, because the node requirements are for everyone, and we are talking about a very specific use case here. And lastly, I'm also confused when I click the link for this presentation for the draft. It's 160 pages. I'm not sure I'm looking at the right draft.
There are two drafts, the Arrow draft and the Omni draft. The Omni draft is 160 pages, yes.
Okay, Tim?
Yeah, just going to echo a little bit about what Eric and David said. You know, as author of BIS, we talked about this and don't think, you know, that SEND should stay there just for this use case. There's just not enough, you know, we've had enough runs at this. There's not enough running existing code, so we think it should be removed.
Okay, so I'm not ready to publish code yet, but that's in the plans. When we get to the point that we are publishing code, is that something that would be considered at that point?
No, because we think this is a special use case, as David said. We think that this is beyond, you know, node requirements. We don't want general nodes implementing SEND. That's not something, a message we want to be sending to people at this point.
Okay, Philip?
Philip Teasel, SAP, speaking as someone who is currently in the phase of rolling out a lot of IPv6 stuff internally. And we're feeling a lot of pain from security recommendations that are outdated, old, and very hard to implement and very hard, actually to commit. And if we would add SEND again to the node requirements, this would really, really hurt people who actually try to implement IPv6 now, because the security departments would say, oh, there's the secure mechanism, please use it. And then you end up in a very, very bad situation. So I strongly oppose reinstating SEND anywhere.
Can I just comment on that? I don't think we're necessarily going to say that the send must be implemented by all IPv6 nodes. I think there's language that can be used to say that it's used for cases like the Omni link. I don't think it's a must that I'm asking for.
Yeah. Sorry, Tim, go on.
Yeah, the issue, Fred, is going to be that things like the NIST, US Gov profile, and other governments read node requirements very, very carefully. And if we don't remove this, somebody's going to say, you have to do this. And that is why we should take it out. It shouldn't be there because that's what will happen 100%. Is some profile or some other document will look at node requirements and say send has to be implemented for security reasons, and people, well, we say people read, they don't, and that will end very poorly.
And
right, Tim, but at the same time, not everything that's in the node's requirements is a must or even a should.
I agree, but I don't think we're even couching this as a solution anymore. I mean, I'm on the other side of this, Fred.
If I can just clarify, I mean, that's exactly what node requirements does. It's the requirements for what should be in every node, so it's not the place to put optional things.
Yeah, Jelinkova, no hats on actually, but Fred, could you please elaborate? Because yes, I have to confess, I have not read the draft. So how general is your node, right? Because node requirements, it's about, an average IPv6 only node. If you have a special case when Omni is used, I do not think, we need to put the burden, we need to add the burden of implementing it to every other single node, right? There are other RFCs which are not a node requirement, but they could be maybe implemented by nodes which need it. That's fine, right? So I'm still not sure why you think every single node around needs to do this. Is it like are going to take a random, I don't know, laptop, Android, iPhone, and make them use this or not?
Not every node needs to implement Omni. In fact, very few nodes do. But the ones that do really need to have this kind of a mechanism.
Yeah, so why cannot you have a Omni node requirements in form of RFC, RFP you give to a vendor or whatever, right? It looks to me like it's a separate set of requirements. I don't even know what else Omni requires, right? Maybe there are some other additional protocol requirements which do not apply, which are not applicable to random node. So, and now with my chair's hat on, I do feel like, there have been a lot of arguments against this. So if you think it should be there, we definitely need to understand better why.
Tobias Siebig, Max Planck Institute for Informatics. I would like to re-echo the point about if we put things into documents that might be picked up by other people, especially security stuff, it can be surprisingly hard to get rid of them if we figure out that they might not have been the right thing to put in there and that kind of requirements language at that point in time, like 10 years later, or if we are dealing with people who do not really understand BCP 14, which sadly also happens a lot for security people and policymakers. So I would really like to strengthen that point before, because we currently have that same issue with BCP 194.
Okay, thank you. So for the first time in a long time, we actually have time for the time allowed talks. So please proceed.
Hello, can you hear me?
Yes, we can.
Yes, we can. Thank you. Hello, this is Safwan from GT. My topic is how to support deterministic forwarding in the IPv6 data plane. Next, please. So supporting deterministic forwarding in IPv6 networks mainly focus on two problems. One is explicit routing and the other is cross-settings. For explicit routing, different hops may use different scheduling parameters such as different time slot, different delay level, and different worst case latency to achieve .NET queues. For post needs, the certain state is held in the packet without relying on maintaining the flow state and transit node. That is an important principle of .NET enhanced data plane for meeting large scaling requirements. So the solution is to define CRH20, which is a variant of CRH that is defined in RFC 9631 to carry scheduling budget per compact segment for the .NET explicit routing keys. In the figure, the fields to indicate the segment type, resource type, and common resource indication shared by all segments, and individual resource indication for each segment. There are also some design considerations for this solution. Firstly, we decouple the scheduling metadata and the topology instructions, such as MPS label, to save the number of instructions and signaling advertisement cost. Secondly, we never rely on dynamic fixed state for the purpose of queuing scheduling and segment compression knowledge for packet parsing and decoding. Next page. So please see this topic is necessary that define the complex routing head with additional resource indications may be used for scenarios other than .NET forwarding. So welcome any questions and comments. Thank you.
Zafar from Cisco. Just a quick comment. CRH is it okay? CRH is experimental. You are mentioning your draft being a standard track. I think it should be experimental. And also there is some overlapping work in the source routing area for this problem space.
Okay, I think we will change the type.
John Linko with a head chairs on, chair's hat on Friday. I think it's another case which we briefly mentioned in the chair's presentation, when there is a problem and solution which belongs to another group, and you're proposing some IPv6 modification to solve it. Therefore, we'd like to get a feedback from, I believe, that networking group, or at least the chairs, confirming that this is a problem, this is worth solving, and then we obviously will be happy to work on implementation details for the solution, because I am not sure we shall discuss the problem and the solution here, because I'm not sure this group is not necessary, has all required audience
Yeah.
and
Yes, the discussion .NET will be synchronized in Paris.
Okay, well, thank you. I think we're ready for the next talk.
Hello, I'm Yalo from ZT, and this presentation is about problem statement with aggregate header limit for IPv6. That's really small. So here's a summary of the draft. So the concept of aggregate header limit is first proposed in IFC 8883. So although there are some texts described around the aggregate header limit, for example, it is related with device passing buffer or processing limit. Packet would be discarded or sent to a slow path if the limit is exceeded. but there's not a definition clear enough for AHL. So before we discuss about the problem, we first proposed a definition of the aggregate header limit for IPv6 in this document. So IPv6 AHL is the total header size, e.g. From the IPv6 header chain as well as any headers that are part of the network encapsulation up to the innermost transport layer that the router is able to process at full forwarding rate, for example, at fast pass. So why the IPv6 AHL, the nodes or the paths need to be availed? The first reason is that the total packet header chain size is increasing greatly in IPv6, especially for SRv6. A third reason is that devices have different processing limits after limit exceeding. So it may drop the packet or send to the slow path. So for a network consists of devices from different vendors, it's hard to manage. Third reason is that parse calculation or packet encapsulation without awareness of the AHL of the path may result in packets with larger header size that downstream nodes are able to process. So about the collection considerations, first is the PMTUD style. So there's an already ICMPv6 error for headers too long for aggregate header limiting, but it may not always work well due to the same reasons as for IFC 8201. And the second is PMTUD style. HBH for pass MTU style. So similarly, you can define an hop by hop option for IPv6 aggregate header limit collecting purpose, but in this way, the AHG collector may be smaller than the size that the pass is actually able to process. Because there are some transit nodes, although it has smaller AHL, but it only forwards the packet based on DA. So you may collect it as AHL of the path. So the third is IGP MSD style. So we think that signaling can be easily supported, and the IPv6 AHL can all the nodes can be collected regardless amount of all the types of the path. And next steps, so my welcome feedback and comments is the definition of IPv6 AHL needed. So we used to consider to propose a clear definition for AHL, but it seems a little bit out of 6 months scope because you have to consider for the MPLS or other encapsulations. So the second is a collection of IPv6 AHL required. So, and the next steps will work on the IPv6 AHL collection mechanism, especially for the signaling part after there's a consensus on the problem spacing 6 meg. So you can find some previous comments in the following links. That's all. Thank you.
Okay, yeah, please be quick. We have like 40 seconds.
Quick and meat, that's not correct. So Eric Vink. So as I said, nice ID. On your previous slide, you describe AHL until the innermost transport header. Not all packets contain a transport header. Sometimes they contain a frame or another IP packet, so you need to change the wording there. Nothing bad, really. Now, on the two first options on the right-hand side of the slide, I'm afraid that if you send to a third party the AHL, it allows network reconnaissance and maybe getting some hints about what kind of operating system are they node there. So I understand it's useful, but it's useful as well for bad actors maybe. So their security consideration must be explained, I think, there. Thank you.
Okay, thank you for comments. Verify the draft.
Okay, yes, so thank you. We shall continue discussion on the list for the sake of time. Thank you very much for presenting. Ah, sorry.
Yes. Okay.
Oh, hold on.
This draft is about extending IPv6 for SRv6 set-related information validation. So as we know, IPv6 addresses, especially SRv6, can be related with many extra information now, but there's no mechanism to validate it. So this is a typical scenario. So for the EVPN data plan failure detection for MPLS EVPN, there's already RFC that's quite new that it detect data plan failures of MPLS EVPN using MPLS SP ping. And the main procedure is the echo request is sent from the egress PE to ingress PE to egress PE. And the egress PE validates the EVPN related information in the echo request. Then the egress PE sends the result of the validation in the echo reply. So for SRv6 VPN or EVPN, there are already many implementations, and the requirement for data plan failure detection is similar. So we first proposed a draft in BAS to talk about the SRv6 EVPN validation mechanism and presented in IETF 120. And so the comments we received mainly about, there are two parts about the work. The first is the encoding or the contents part for specific scenario, for example, for the SRv6 EVPN validation. So this belongs to BAS. And the second part is there's the basic request and reply mechanism, or we call the container. It should belong to a 6-man or interarea. So this is this document talks about. So this is a very brief mechanism. So because of the limited time, so the basic mechanism is simple. So we define two new ICMPv6 messages. One for the validation request. It's use ICMPv extension structure to carry the information to be verified, and the second message is ICMPv6 validation reply. So in the coding it indicates the validation result. So it is a point-to-point validation. So request is sent directly to the node to be verified. So similar to ping. So welcome feedbacks, comments, and cooperation. So is this extensions for ICMPv6 we propose in the document appropriate, or is there any better ideas? So, and we'll continue to work on this basic container path mechanism. Yeah, that's all. Thank you.
Yeah, thank you. So there's discussion should be on the list, but I think this would also fall under, we would need to hear from Spring as to whether they would like us to pursue this.
Yeah, I've used to present this to Spring, but the suggestions I got is because we are extending the ICMPv6. So
I understand, but they have to tell us they think they need something like this.
okay, sure, maybe from the Spring or BAS. Okay, thank you.
And the last presentation, who's actually presenting? Yao, are you online? Oh, we seem to be losing presenters today. So, no presenters for this one? Ah, well, in this case, this concludes 6-man in Bangkok. Thank you very much for being here this morning. And I see you all in Madrid.
Thank you. Enjoy your remaining time in Bangkok.